to the greater community. Before we get started, just a brief on Indiaspora itself. We are a nonprofit network that really gets the 35 million strong diaspora together to be a force for good. We started here in the United States, but now have chapters in UK, Canada, Singapore, UAE, Australia, and India. We have some major upcoming events. We are doing a large global forum in Bangalore this March 22nd to 24th, where we expect 500 global diaspora leaders from over 30 countries to participate. And it will be followed on the next day by the AI Summit, where we expect a very large audience of Indians to join us as well. If you want to get more information on these events, you can go to our website, indiaspora.org. We also have one of the best newsletters that communicates with the entire diaspora. So please feel free to go to our website and subscribe to our newsletter and keep in touch with us and the greater community at large. So with that, this is our second episode on the health series. The first one was around heart health. And this one is going to focus on something that's very prevalent in our community, which is diabetes. Just to give you some statistics to get this started, Indians, and if you include the greater South Asians, if you will, there are 90 million of us who have diabetes, and it's projected to be 150 million by 2045. Startling number. 8.7% of the population has diabetes, and it's expected to grow to 11.3%. We are 4 times more likely than Europeans to get diabetes. This is not a great stat we want to excel in. And I think this requires both a lot of information, prevention, so that we don't get to the diabetic stage. And for this, I'm so privileged to have, once again, our 2-time former Surgeon General, Dr. Vivek Murthy, to join us and to kind of kick us off, make some remarks, and then maybe a couple of questions for you, and then we'll get on with the panel. So Vivek, welcome to the second part of our series.
Well, thank you so much, Amar, for the warm welcome and allowing me to be a part of this conversation tonight. I also just want to thank the whole Indiaspora team for bringing us together to talk about how we can improve the health of the South Asian community. Like Amar was saying, we excel in a lot of areas, academics, economic accomplishments, all kinds of achievements. But one place where I worry about our community is with regard to health. And I think the series that Indiaspora is leading, starting with heart health, now with diabetes, is all part of an effort to help us understand what we can do to help mitigate some of the increased risk that our community is at for conditions like diabetes. So, as Emar mentioned, the topic of diabetes is very relevant. We'll talk about a lot of data, about statistics, about what we can do about it. But just at a very human level, I suspect that if many of you think about your families, whether back in India or the diaspora across the world, you have likely over the years noticed that more and more people are being diagnosed with diabetes. I've certainly seen that in my extended family in India. I've seen that in family members here in the United States as well. And this is not a coincidence. This is happening, across the board. The numbers that we have of people who have been diagnosed with diabetes, especially in South Asia, is almost definitely an undercount. We have a huge detection challenge as well. There are many people with diabetes who are not diagnosed. So the real numbers are likely even higher. But one thing that's important for us to know is that our bodies, for genetic reasons, behave differently than perhaps other people in the population, which is why we are at increased risk of diabetes compared to white populations, around anywhere from a 2 to 4 fold increase in risk. But we also tend to develop diabetes at an earlier age, 5 to 10 years earlier, in fact. Many people I have talked to in our community say, well, I went to the doctor and the doctor said that my weight is fine. So I'm probably not at increased risk for diabetes. My BMI, my body mass index, is 24, so it's under 25, which is the overweight threshold, so I'm okay. But one thing many clinicians may also not know, unless they have expertise, in diabetes in the South Asian population, is that our risk of diabetes increases below 25, below the threshold for being overweight. So even with the body mass index of 23 or 24, which are considered normal, in the general population, our population may in fact already be at increased risk. So this is why it's so important for us to have this conversation, because you can't tell from the outside, can't always tell by somebody's weight, can always tell by how they look whether or not they're at increased risk. And that's why we've got to understand how we can protect our families and our community more broadly.
Thanks, Vivek. I know you've also written books. You're an entrepreneur. You've done so much for our community. And you're right on. In my family, my grandparents had diabetes. My father was a diabetic. 3 of my siblings are diabetic. So it's super prevalent. So as Surgeon General, when you were there, what are some of the other things that you learned, that you informed the population at large in terms of this type of disease? How do you prevent it? How do you take action? What is your advice at a high level?
Well, the good news is there are things we can do to help reduce our risk. And while some of our risk may be related to our genetics, to things that we're born with, for example, like we know that South Asian populations tend to accumulate fat viscerally, that's in their abdomen. We also know that partly as a result of that, they tend to have higher insulin resistance. They tend to deposit more fat in the muscles as well, which is why someone can look slim but have a high amount of insulin resistance and hence increased risk of diabetes. But that doesn't mean that there's nothing we can do, because it turns out that when it comes to our diet, when it comes to our exercise patterns, that there are, in fact, measures we can take to help reduce our risk. We can also do more to help monitor our risk level, whether that's our hemoglobin A1C, which is our measure of long-term glucose control, or also measuring our visceral fat, which is not just looking at overall body fat, but how much fat specifically is collected in the abdominal area around our visceral organs. And that can also help us to understand when our risk has increased. And that's part of what we're going to talk about on this panel today. What are the dietary changes we can make? What are the physical activity shifts that we can make in our own life? I'll lastly just say on the diet front, though, that many of us, I dealt with this in my own family because my father has diabetes. 2 of his brothers have diabetes. All 3 of his sisters have diabetes. On my mother's side, there's diabetes as well. And the question that many of them asked is, they said, well, I'm eating a healthy diet. I'm eating, it's primarily, what are you eating? Well, it's primarily rice. Is primarily increasingly refined carbohydrates as cities have become more and more industrialized, and the food, so supply has also become more processed and industrialized. And they thought that they were eating relatively healthy, but it turns out that they had a lot of refined carbohydrates and a lot of carbohydrates like rice and chapatis and rotis and others, which we think of as healthy, and they have a lot of nutritional components to them. But when it comes to contributing to our risk of diabetes, to obesity and weight gain over time, it tends that they don't work out, as well from a health perspective as we sometimes may think. And so we have to more consciously think about our composition of our diet. How do we reduce refined carbohydrates? How do we increase our protein intake? And these are things, again, which we have to do intentionally. Lastly, just say that part of the reason this is not always easy is because the environment around us doesn't always help us in this regard. If you look at the cafeterias in many of your workplaces, if you look at even the cafeterias in the schools that our kids go to, if you look at the vending machines in sports stadiums and other public venues, much of what you find there are highly processed foods that have a lot of refined carbohydrates. And so sometimes we have to make an extra effort to ensure that our diet that we have is consistent with real health and reducing our risk of diabetes. And that's one of the reasons we're here to talk about this, because it might be hard to do alone, but if we can work together in figuring out how to make these changes, they can be a lot more sustainable. And that's, I'll ask you to share, this is something I had to do in my own life. I was tracking my hemoglobin A1C. And if you met me, and I've met a number of you who are on this call, you would look at me and you'd say, hey, you don't look like you're overweight. And I'm not. overweight. My body mass index is below 25. But I started noticing that my hemoglobin A1C was creeping up over the years, and it was actually getting to the pre-diabetic range, even though I had not put on any additional weight. And I had to really think about it. And I realized that over the years, I had actually put on more visceral fat. I realized that I had more refined carbohydrates in my diet that I had really accounted for. So I started making some shifts and changes. I started increasing my protein intake. I stopped eating late at night. I started reducing significantly my intake of rice and other sort of simple carbs. And what I found was that that was actually helpful to me in reducing my visceral fat and reducing my overall body mass index and ultimately in reducing my A1C. But the only reason I was able to make these changes was because two good friends of mine who are also South Asian and we, the three of us, talk about our health on a regular basis. And we made a pact with each other to make these changes, like in our life. And I had tried to make dietary changes, other changes in the past, and I would succeed and then I would revert after some time. But these changes, because we did them together, we've been able to sustain them for a few years now. So that's why I mentioned, like, this work is not easy, but when we make pacts to do it together, when we help each other, it's much more sustainable.
Great. Thank you so much for that sage advice, Vivek. I know you'll be tuned in for the rest of the show as well, and feel free to jump in as appropriate. But really, one of the things that we uncovered a year ago at Indiaspora when we did our impact report was there's so much talent in our community, especially in the medical community. There's 75,000 doctors like you and others on this panel who are of Indian origin, and you're such a great resource for us because you represent us as a community and as a DNA as well, right? Because our health requirements and background is so different than the European. And so I think you help us in so many ways. I really want to thank you once again for being part of this. And please stay tuned with us for the rest of the show. So thank you.
Thanks so much, Gemma. I really appreciate it. And looking forward to the rest of the panel.
Great. And now on with the show, as they say. We have our Indiaspora Founder Circle member with us, Nalini Saligram. Nalini Saligram has been a one-woman band to really try and prevent non-communicable diseases. And for her, and we'll find out more, why diabetes is at the center of the work she does at Arogya World that she founded, just to stop preventing diabetes, especially in India, where I said the numbers are startling. We could have over 100 million people soon in India suffering from diabetes, which is not a good stat. She's also an Ashoka Scholar. She has a PhD from IISc in Bangalore. And without further ado, I want to welcome Nalini, and she'll welcome her panelists as well. Thank you, Nalini.
Thank you. Thank you very much, MR. I'm really looking forward to this conversation, and we'll unpack a lot of what Dr. Murthy was talking about with our real distinguished panelists here. Thank you, Dr. Murthy, for your introductory pace-setting remarks. I have with me the privilege of speaking to three real experts. Dr. Venkat Narayan is the Executive Director of Emory's Global Diabetes Research Center. He's also Professor of Global Health and Epidemiology at the Rollins School of Public Health at Emory and Professor of Medicine and Endocrinology at Emory University School of Medicine. A leading international diabetes expert, he's an elected member of the US National Academy of Medicine and is noted for his substantial multidisciplinary work in diabetes and non-communicable diseases, epidemiology, pathophysiology, translation research, and public health. Welcome, Venkat.
Thank you.
Our second panelist is Dr. Ravi Ramaswami. He's a professor in the Department of Medicine and professor at the Department of Biochemistry and Molecular Pharmacology at NYU's Grossman School of Medicine. He's well known for his research to understand the metabolic and inflammatory mechanisms underlying diabetic cardiovascular complications. Dr. Alka Kanaya is professor of medicine and epidemiology, biostatistics at the University of California in San Francisco. She's an expert in type 2 diabetes, obesity, and cardiovascular disease. And she's the principal investigator and the founder and creator of the Masala study, which is so important to us South Asians in the US. So we'll jump straight into Q&A, and I hope, MR, at some other stage, we'll get a chance for people to know what Arogya does. We may not get into it today. We've got a lot of stuff to cover. But I'll start with you, Venkat. You heard some alarming statistics. In Arogya, we use the 215 million Indians with diabetes because that's the latest Lancet study, global study. And we also know Indians get diabetes very early. And we also know that in cities like Chennai, 75% of the adults are either diabetic or pre-diabetic. How do you wrap your head around these huge numbers? So I just wanted to ask you, why do Indians get diabetes in such large numbers? And what about Indian Americans? How do we compare to other Americans in terms of diabetes risk? And in general, why are we at such high risk?
Yeah, thank you, Nalini. I think, again, I've been studying diabetes since 1992 from various different angles. And I think when you think of diabetes, why are South Asians or Indians at higher risk for diabetes? There are two axes that we should pay attention to. One is the biological axis, and the other one is the lifestyle and environmental axis, which we heard a little bit about. So I'm going to leave the lifestyle and environmental axes to Alka to cover when she talks about prevention. I want us to think more deeply at the biological level. Why are South Asians at high risk of diabetes? And I think there are three fundamental reasons, potential fundamental reasons. First, increasingly, we are finding that South Asian populations, the Indian populations, are not secreting enough insulin compared to other populations. And that says that probably some problem with the islet cells of the pancreas, which secrete both insulin and glucagon, and that needs to be studied through basic research. Secondly, South Asian, we are low in muscle mass, relative to other populations, and muscle is necessary for energy expenditure, but we seem to be low in muscle mass. And the third, we very rapidly accumulate fat in the liver compared to other populations. So these three things together conspire. Number one, we don't secrete insulin, so we don't have the metabolic capacity. And second, our muscle is mass is low, so we don't burn glucose readily. And third, we are easily prone to depositing liver fat in the liver, so therefore the insulin doesn't act well. And I think this requires focused research. And we have spoken about the numbers. There's probably over 800 million people with diabetes worldwide, a quarter of whom are South Asians, are Indians, not even South Asians, they're Indians, a quarter. Okay. But when you look at the amount of research that comes out of Indian populations, whether in India or in the diaspora, it's about 1 to 2%. So there is a huge mismatch between the knowledge and our application of that knowledge. Our knowledge is borrowed from other populations. And I would argue that this community needs to fix that problem. I think unless we invest more in the research at the biological level as to why is it that South Asians are more prone, I don't think we're going to solve the problem. But I think with investment of research, we probably might be the population where the problem of diabetes ultimately gets solved. So I would urge that we start thinking in terms of how do we address the research problem? Again, it's not just Indians. When you look at the NIH research across the Asian populations are about 8 or 9% of the country, but 0.2% of NIH dollars is what is spent on studying the health of Asian population. So there is an underrepresentation, and this powerful community, well-educated, wealthy community needs to step up and also make an argument for studying this problem better. People like Alka and I, we are doing the best we can under the circumstances, but I want to point to you that we are not going to solve the problem unless we solve the biology.
Well, thank you. Thank you, Venkat, for the call to action right from at the start. Thank you very much. I'll move on to Ravi. So again, a fundamental question, Ravi. Why does diabetes lead to heart disease, and to other complications? What is the fundamental metabolic and physiologic reason? Already we learned about biology that leads to diabetes, but please tell us why now heart disease and other things, a stroke.
Absolutely. Fantastic question that I've been working on since, I would say, 1992, to be precise, when I started my career in California initially. So let's think of what is needed for the heart to function normally. It needs a lot of energy to function, and glucose provides that energy. Burning of glucose provides that energy, and burning of fat provides that energy. Okay, so in diabetes, what happens is glucose is hijacked to pathways that are not producing energy. And as a consequence, what happens is that the heart muscle proteins are getting modified, and it is not able to do a contractile properties normally that it should. So that's one problem. And then the second aspect of it is the blood flow to the organ itself is impaired because the vessels are getting modified, and the signaling mechanisms that are operational in the blood vessels are getting modified as well. So as a consequence, what happens is that not only do you have a deficit in energy production in the heart, modification of the muscle in the heart that leads to poor contractility and poor blood supply to the heart itself. Added to this, what happens is that your clotting mechanisms, especially the platelet properties, are getting impaired in diabetes as well. These are all consequences of glucose getting siphoned off into pathways that it normally shouldn't go into. And as a consequence, what happens is that there's a lot of clotting issues that we see in diabetics, above and beyond what you see in a non-diabetic population, right? And so there's a fundamental mechanism that is going on. So one could say that if I get rid of the glucose abnormality, would I be able to prevent the cardiovascular complications from happening? The simple answer is no. Tight control of glucose reduces the time it takes for the complications to happen. It only delays it. There are a number of clinical studies and ongoing trials, the longitudinal studies, that clearly informs us that what you're doing is you're delaying the progression of complications and not eliminating it. So that, to me, I think the fundamental issue is we as Indians, how can we participate in identifying these different pathways that are existing in the animal models, and which some of it all has been shown to exist in humans as well. So how do we come up with a fundamental understanding to help us solve this problem?
So just to clarify, Ravi, if you are diabetic, you have a very high chance of getting complications like heart disease and others diseases, but you can delay it if you take care, correct?
Yeah, absolutely.
All right, thank you. So Alka, now over to you. What can we do to prevent these diseases? What is the science behind this prevention? And then which is more important, diet or exercise? And then is hemoglobin A1C the best test for our community, for diagnosing diabetes?
Okay, let me take one at a time. So thank you for asking about the science behind diabetes prevention. There have been many studies around the world that have used diet and exercise as the lifestyle method to prevent diabetes. And they've all found something like a 50 to 60% reduction in those who develop diabetes. These are randomized trials. So half the people were randomized to changing diet and improving exercise by walking, and the other half were not given any instructions to do those changes. And the people who did make the changes were able to reduce their incidence of developing diabetes by about half compared to the people who did nothing. But what happens when we do these studies in India? And there have been studies that have tried to replicate these results in India. And unfortunately, these interventions that promote, healthier diet and lifestyle work about half as well in Indians compared to other populations. So the risk reduction was about 30% in India versus about 60% in the US or in China or in Finland or in Mexico. So why is that? Why did the same intervention not work as well? And this goes back to what Venkat was saying, is that if we think about the pathophysiology of diabetes, this really sheds light at what we do when we improve our diet and when we exercise. We are working on making our muscles burn off some of the excess glucose in our system when we exercise. When we improve our diet, we're helping to reduce the amount of fat that may be deposited in the liver. But we're not able to do something to increase the secretion of insulin. And both Venkat and I have, really spent some time thinking about this and seeing that this may be really the biggest problem in the South Asian diabetes pathophysiology, is the secretion of insulin is not easy to reverse with diet and lifestyle changes. And that just speaks to us having a gap in the knowledge. And what can we do in terms of behavioral interventions to reduce the incidence of diabetes if it's not going to be only as simple as diet and exercise? So that's the science behind it. And what the gaps are is we don't really know how to reverse this pancreatic insulin secretion problem. The second question you asked me was about hemoglobin A1C. That is probably the easiest test for a patient to do because you don't need to fast. You just show up to the lab, do a simple blood test, and go home. What we have found when we've looked at data in Masala, as well as comparing to data from India with the CARS study that Venkat leads, is that Indians tend to run slightly higher than other populations with their hemoglobin A1C level. And that can be because of nutritional deficiencies or differences in the hemoglobin protein. So not everybody runs high, but there's a higher proportion of Indians that seem to run high on the hemoglobin A1C. So as a primary care doctor myself, I push the fasting glucose test as something that I would advise all of my patients to do every single year, regardless of their BMI, just because I know South Asians are at very high risk of diabetes, given what we've talked about. Is a fasting glucose test costs about, 1/20th the amount of a hemoglobin A1C, and it doesn't run that risk of being high. If I see that my patient has elevated fasting glucose over 126, then I will follow up by getting a hemoglobin A1C or a repeat fasting glucose test. So I think that, on a population level, fasting glucose is cheaper and is something that I feel is a better test for South Asians.
Great. Thank you, because that has always been confusing whether to go with A1C or not. So that's really good to know. Just to summarize then, hey, diabetes is not inevitable, it is preventable, but we have a lot more science to understand and physiology to understand in our community, in our population. Okay. Venkat, I want to unpack one other thing that Dr. Murthy alluded to. He talked about visceral fat. So can you tell us a little bit about this thin fat Indian syndrome and why should we measure visceral fat? And is obesity truly a risk factor for Indians when thin Indians with BMI 17 get diabetes? So over to you, Venkat.
This idea of the thin fat Indian was kind of initially popularized from a picture. That is Dr. Yatkin and Yajnik. Yajnik is an Indian physician. They both weighed each other, measured each other. Their BMIs were identical. I think it was 22 or so, I can't remember. But their fat distribution in the body was widely different. For the same BMI, Yajnik had a lot of fat in his body, whereas Yatkin had much lower fat in the body. What was not taken into account was Yatkin was a marathon runner, whereas Yajnik was something else. And so essentially that is how the idea began. And it goes back to a hypothesis originally put forward by Dr. Barker about the intergenerational effects. Like, for example, there was a study in India called the Delhi birth cohort study. And there they took children at birth, measured them, and then followed them up for the next 25, 30 years. So children in India, you're talking about 60s and 70s India, where there was a lot of undernourished children being born, a lot of stunted children being born. The children that were well nourished at birth retained their glucose levels to age 25. They maintained normalcy. Whereas the children who were undernourished, low birth weight, or stunted before age 25, they were developing pre-diabetes, even diabetes. So at that time, this paper was published in the New England Journal of Medicine, and the hypothesis was, the popular hypothesis, that Indians had more fat relative to others, and that's why they are developing diabetes, because the insulin is not acting. That is partly true. But now looking back, if I was to rewrite that paper, I would argue that those Indian children who were born undernourished or low birth weight were not secreting insulin to start with. So therefore, very little fat deposition, their body did not have the ability to compensate. So I think that is where it is. So, and I think in the last 4 or 5 years, this idea is becoming much more interesting. When you, for example, compare the Indians in Chennai with the Pima Indians in Arizona, they both, by age 50, have very high prevalence. 55% of both populations have half the population of diabetes. So they're both at high risk. But the Pima Indians are 7 BMI units heavier and 25 centimeters larger in the waist. But yet their diabetes rates are similar. So that means it has to be something other than obesity. And when you examine the glucoses, we find exactly what Alka said. In the Indians, the problem was high fasting glucose, whereas in the Pimas, it was high 2-hour glucose. So your A1C, hemoglobin A1C, cannot tell that difference as to where the glucose is coming from. Whereas that is why the importance of the fasting glucose is important. And secondly, when we actually measured both insulin secretion and insulin resistance, the Pimas were highly insulin resistant. Even normal weight, normal glucose Pimas were highly insulin resistant compared to the Indians, whereas Indians were secreting less insulin. So I go back to this issue that the thin fat Indian is true, but it also needs to be viewed in the context of Indians not secreting enough insulin.
Right. So if obesity is a predictor of diabetes or a risk factor for diabetes in Americans, in Indians, it's not necessarily true.
No, I wouldn't say that. I think I wouldn't jump to that conclusion. I think they're both important. Okay, they're both important. But the question is, okay, let's now, of late, there's been a lot of work on the fact that type 2 diabetes might be multiple diseases. There might be type 2 diabetes which is driven largely by poor insulin secretion. There might be type 2 diabetes that is driven largely by obesity and high insulin resistance. There might be diabetes because of aging and the changes that happen. But when you look at different populations of the world, and there are a number of studies done, almost all populations have these different types. But the Indian population has predominantly the insulin deficient variety, which means that you start off being insulin deficient, and if you become obese, you're at double, it's a double whammy. So, but I would not, go as far as saying obesity is not a risk factor. I mean, that would be dangerous, and I wouldn't say that.
Good. All right. Thank you. Alka, I wanted to talk about the new dietary guidelines in America. They have changed very recently and to include more fat and more protein, and that's more confusing now for ordinary consumers. So I just wanted to understand from you what you tell your patients about, what they should eat and about how to navigate the diabetes landscape in the US.
Yes. So the new guidelines do emphasize eating less processed foods and more whole foods. That includes fruits, vegetables, dairy, nut, meat, poultry, and fish. Where they are a little controversial is that they prioritize using animal-based protein and full-fat dairy over grains and vegetable sources of protein. They also elevate whole fat or full fat dairy like milk and butter as part of a healthy diet. And there's softer alcohol guidance in these, and the whole pyramid that we were used to is sort of inverted in the new guidelines. So there's some controversies here. So what do I tell my patients? our diets are so closely aligned with our family and our culture, and diet is very hard to change. So people who do want to make a change really have to be motivated. And I think it's not only an individual who can make this change, because it's a change that has to happen for a lifetime. You need a supportive structure of people around you. Like Dr. Murthy was saying, having other people around you in your social network, in your family, also make these changes will make it a lot easier for you to be consistent. So my guidance is to follow a diet that can fit into your life, and the people around you can also make these changes. I'm a big believer in moderation. Moderation is best. I do not think anyone can live an entire life on an extreme diet, one that is very, very low in carbohydrate and very, very high in protein and fat, or the reverse, very high, carbohydrate and low in fat. So there's all these fad diets that come and go. So my guidance to patients is minimize refined carbohydrates. So really try to cut out the white breads, the white pasta, the white rice. Try to get more fiber in your food. So whole grains and other fresh leafy vegetables. Don't overcook your vegetables. Keep them as much fiber as possible. Eat healthy fats and protein at each meal. And I think this is the key for vegetarians, that if you are a vegetarian, it is harder to get enough protein from usual vegetarian sources. In a large study that was done in India, and around the world called the Pure Study, what we found was that the people from India, especially from South India, were eating about 60 to 65% carbohydrates in their diet, where the goal is not to have an overwhelming amount of carbohydrates. Less than 50% is better, especially if someone is diabetic. And then be mindful when you eat. Eat meals earlier in the day. And so I really try to put a time on that, like your last meal should be happening before 7 p.m. And that is very, very difficult for South Asians, because we are a very, social culture. We go out a lot. We love our parties. We love our, weddings and big celebrations. And those meals are served after 10 p.m. often. And this is a really big problem, because then your body, your insulin secretion doesn't get a break. And that's a really massive problem for people with diabetes, is you don't get a chance to digest the food and you don't get a chance to burn those calories. So avoid nighttime snacking, eat your meal before 7 p.m., your last meal.
Good. Okay. Thank you. That is very clear advice. Low carb, refined sugars are out, and then eat early. So that's very clear advice. So Venkat, I just wanted to ask you very quickly, can a low carb diet, high protein diet really work for all people? Do we need to customize the diet advice we give to different people, or personalize it in some ways?
Yeah, I mean, those are general average guidelines. There was a recent paper in India from Dr. Mohan's group, basically modeling, showing that if you took the Indian diet, a high proportion of energy in the Indian diet comes from carbohydrates. Okay, if you even substituted a small amount of carbohydrates with proteins, then it could have potential reductions in diabetes risk. I mean, this is in a population where protein intake is low in general, and carbohydrate intake, particularly refined carbohydrate intake, is very high. So I think that's the context we should have in mind. So I think that general advice is generally correct, but we also need to qualify it. What do you mean by low and high? That needs to be qualified. And also there are good carbohydrates and not so good carbohydrates. And similarly, protein, the quality of protein matters. And similarly, the quality of fat also matters. When there are some fats which are good for you, like monosaturated, polysaturated fats are good for you, whereas the saturated fats in large quantities, particularly when you heat them, fry them, keep them overnight and fry them again, you generate free radicals. It's also bad for your heart, etc. So that is one thing. That said, there is a lot of variation across individuals. If two individuals ate the same food, their metabolic response might be different. So this is why, when it comes to the more sophisticated way of managing diabetes risk and diabetes, tools such as continuous glucose monitoring are going to become more and more useful. Like, for example, we might be able to get into more precision. Person A, based on their continuous glucose monitoring and different foods, their responses to it, we might be able to customize different treatments or different diets for different people. I think that is a field that is likely to go. So I would start with that simple advice, follow exactly what Alka said. And then beyond that, if there are still problems, then maybe the next step would be, let's try and see whether you require more personalization, more precision to your diet management. I think that's the way to take it. But I think this field is also going to grow as, things like the continuous glucose monitoring, wearables to measure diet, physical activity, and also sleep. Sleep is a very important, biological requirement. A lot of South Asians have either short duration sleep or bad quality sleep. Again, that goes back to you've had your dinner at 10 or 11 at night, you don't go to bed till 12 or 1, and then you wake up at 4 or 5. That's a problem. One of the things that I've always done for many, many years, I don't eat anything after 6 o'clock unless I go to a party or whatever. And generally, I go to bed before 9. I never watch television, and I wake up at 5. I often say when I lie down, I'm dead. When I wake up, I'm alive. So that's what is important, I think. We have to manage the whole thing well.
Right. So I just, wanted to make a comment about Arogya's work a little bit, because we are delivering lifestyle change advice to people in the community setting in India in large numbers. We've reached some 29.5 million people over the last 15 years in this way. And what I wanted to say is that for groups like us, public health organizations like us, this generalized advice is the way we go. Eat right, exercise, and avoid tobacco is what we communicate, because we are talking to millions of people at the population level. So the question for you was truly, should we continue to do that? Because, for us, that seems to be the simplest way of speaking to consumers. The doctor in India will see a patient for 2.5 minutes, and in those 2.5 minutes, there's no time for lifestyle change advice. So that's the role organizations like us, community-based organizations like us can play a role as long as we do science-based work and deliver science-based advice to people. The trick is in designing the programs correctly. So we have age-appropriate, compelling programs for school children that are games-related, that teach through games why they should take up healthy habits. Then we talk to consumers in rural India on their cell phones, on WhatsApp. And then we have workplace standards, and we have whole cities and Maithali using social media. So we truly are trying to change the way India eats, try to get individuals to change behavior. It's very hard, but that's the role we've taken up. But what I wanted to say is that, hey, even generalized advice is what we are giving at the population level, and that seems to be.
I think that's admirable. The volume of people that you reach out to is admirable, and that advice is a starting point. So I think it's absolutely required, essential. But I think as science evolves, the advice might get a little more, sophisticated as we go forward.
Sure. Great. Okay. Now I come to the question that I, as a interested person in the diabetes community, have been waiting to hear. In your opinion, what is the most compelling? So it's 100 years, since insulin. So this is not a new field, but what is the most compelling diabetes research going on in the field or in your lab? Okay, you can take it either way, whichever way you want to answer it. So Ravi, I'll start with you. What is the most exciting research going on today?
Oh, there are plenty of them. Let me start with the work we have done. One of our molecules is in phase 3 for diabetic cardiovascular complications. This is based on basically preventing glucose from going into alternate pathways. And what we have shown in our preclinical as well as some of the early clinical studies is that this particular pathway, the aldoketoreductase reductase pathway, when you block them, you're able to reduce the energy deficit in the heart. I mean, you're basically able to prevent the energy deficit in the heart. And importantly, what we have also shown is that it also reduces inflammation that comes in this next phase of the cardiovascular disease. Okay. And in terms of the other molecule that is in the safety trial, again, from our research, is the blocker that can negate the function of the receptor for advanced glycation end products. As you know, glucose forms these glycation end products, and when it interacts with the receptor, it can lead to inflammation, all kinds of complications from head to toe. So we have small molecules that have been refined in our lab and that have gone through safety studies and that are ready for prime time in terms of clinical trials. So those are two molecules that have come out from our lab that are being tested in patients. In terms of the general field itself, stem cell therapy has really blossomed in this area. For example, in type 1 diabetes, for example, we're able to grow the islet cells. Now the challenge is how do you prevent the immune cells from attacking them when it is transplanted into the patient? There are a number of trials that are ongoing that have been addressing this issue. Hopefully, one aspect that we have conquered already is the islet cell mass in the pancreas itself. We have conquered that field. Now it's a question of how do you keep them alive and beating or functional without the onslaught of the immune cells attacking them. So the research is going on in that front. And again, in terms of the type 2 diabetes, there are a number of next generation of GLP-1 agonists as well as SGLT2 as well as SGLT1 blockers, combination blockers that are coming in, which may bode well for slowing the diabetic complications much better compared to what we have right now. So these are some of the exciting areas that I see. In terms of research itself, we are using all the AI tools now to really come up with a better understanding of what the proteomics, the genomics data set is informing us from the human studies as well as from the preclinical studies. And my bet is that in the next 5 to 6 years, you're going to see a really number of targets come out from these studies, which are going to be precisely, helpful for Indian population.
Great. We'll pick up on GLP-1 as well as AI in a little bit, but there have been a number of questions also already. So if any of you want to answer some of those, it'll be great. But Venkat, let me get to you to same question. Then I'll come to you as well after that.
Across my colleagues and my partners in India and in the United States, we've been working on a number of issues, but 3 things excite me the most currently. The first is we are trying very hard to get to the bottom of why is it that Indians are not secreting insulin. Number one, establishing that fact and trying to find out why they're not. And to do this, we have undertaken 3 very ambitious projects. First, in Hyderabad, in collaboration with the Asian Institute of Gastroenterology, funded by an Indian government agency, we've set up an endocrine pancreatic facility where we are getting pancreases either from Whipple surgery or in the future from road traffic accident victims. And we will be studying, we're starting to study those pancreases, standardizing the studies to the pancreatic biobank in the United States using the same methods. And that is suggesting already, giving us some clues as to why Indians may not be secreting enough insulin. There might also be a problem in the way Indians are secreting glucagon, which is another hormone that is important in regulating blood glucose. So that's one thing. So we are also pivoting that to establishing a fetal pancreatic biobank in Christian Medical College, Vellore, to try and map come up with an atlas of the beta cell and the alpha cell in Indian fetuses. These are from abortions, to try and see where is the fundamental problem. And we're not happy just studying the problem. We want to try and get into the field of, can you regenerate the islet cells? And we're setting up a facility in IIT Madras. That's another thing. So this is a cluster of studies that I'm very excited about. And in addition to that, as you know, we have a cohort called CARS, which is 22,000 people already in Delhi and Chennai, already followed up for almost 16, 17 years. It's about 4.5 times the size of the Framingham Heart Study. And in the CARS cohort, we have done very detailed phenotyping. It's clear measurements of all the glucose measurements, genomics, epigenomics, metabolomics, which are important to understand the genetics and its expression. And then we are imaging the different parts of the body, the heart, not the pancreas yet, but we would like to do it in the future, the liver. And then increasingly, we've also started imaging the brain. So I think that's the CARS cohort has already given us some very important insights. For example, in the Indians, the moment they develop prediabetes, the moment your glucose goes up beyond a certain range, which is what we call prediabetes, the window to developing diabetes is very narrow. Within 7 to 8 years, they go on to develop diabetes. So if you want to prevent diabetes in Indians, we need to start studies before people become pre-diabetic. You want to arrest the progression from normal to pre-diabetes in the first place. So I think that is also exciting. And thirdly, in the CARS cohort, because we are studying multiple organs, we are studying kidney, we are studying liver, we are studying the brain, we are studying cardiovascular disease, we are able to map the natural history of diabetes and its complications. Particularly excited about the addition of brain, because there is strong indication that a disease like diabetes accelerates dementia. And dementia is not one disease. There's Alzheimer's, there's vascular dementia, there's Lewy body dementia, and all dementias also do overlap. So the CARS cohort is uniquely set up to measure potentially the 14, 15 risk factors involved for dementia and establish this and write the book. And I think this is where Alka's work here in the Indian Americans in the US through the Masala and the extended studies in South Asians is going to be enormous. And that's why Alka and the CARS, we write papers together. And I think we need bodies of work from basic science, epidemiological studies, clinical research, and also more studies of the specific therapies to test. And the final thing that I'm really excited about is deploying artificial intelligence, not just to detect and diagnose diabetes or cardiovascular disease, but perhaps it's going to be a tool to help us coordinate care, whether prevention or treatment. I mean, we can take the work you're doing, Nalini, and use and employ AI to take it to 1 billion people. So I think those are some of the areas that I'm very excited about.
Great. We're running out of time, but Alka, I want to hear you, and then we'll quickly run through a couple of the other questions. And there's so many in the chat as well. But over to you, Alka.
Yeah. So for me, the thing I spend most of my time doing is trying to make the most of our Masala cohort to understand both the biology, but also the social and cultural influences on diabetes and heart disease. We have just doubled the size of our cohort with a new NIH grant. So now we have more Bangladeshis and Pakistanis in Masala, as well as a large group of Indians. And what we found is the differences in diabetes prevalence is profound, with Bangladeshis having 50% diabetes prevalence, 1 out of 2 Bangladeshis. Pakistanis, 40%, Indians, 24%. So it's still higher than any other US group, in fact, because we've done those studies comparing our Indian population to the US. But why is there so much difference among these 3 South Asian immigrant subgroups in the US? And so it's not genetics. We know that because genetics takes many generations to develop, and we have more in common than not in terms of the different genetics of North India. So we are trying to do a deep dive into understanding what is the reason that there's so much more diabetes. Is it social, cultural? Is it dietary? Is it other lifestyle behaviors, stress, etc.? To really understand what are the modifiable risk factors to prevent, because that will give us a window, an opportunity to think about different interventions we can do that, you know, can be done on an individual basis. So I'm really excited about this new pathway in what we're doing.
Great. Okay, I'm going to have all of you rapidly comment on the GLP-1 agonists and their role and revolutionizing diabetes care. So I just want to get your opinions on that, as well as AI. If you want to pick one or the other, that's fine too, because we are really short of time. So we can start with Ravi, and then we'll go down Venkat and then Alka.
Sure. So the GLP-1 agonists, you know, they're doing a fantastic job in terms of managing the sugar per se. In terms of cardiovascular, from my point of view, I've seen two recent studies which highlighted the benefits in reducing the cardiovascular events, particularly the myocardial infarction-related events. And what was striking for me was that in the type 2 diabetics where it was tested, it was only effective in the people with a BMI greater than 27. Anybody less than 25 and less, it didn't help them. I mean, it didn't do anything harm, but it didn't help them control the cardiovascular events. So, and also keep in mind that the GLP-1 agonists are not approved for use in type 1 diabetics. So in terms of their benefit for T1D in terms of cardiovascular complications, it's not known. So again, these are areas that I'd like to see some studies that are coming up and see what the outcome is.
Okay, Venkat?
Yeah, again, I think when you think of GLP, we are all excited about it, and it's probably the second greatest discovery after insulin. There's no question about it. But one of the things, so we did an estimation of worldwide, globally. We said there are, more than 1 billion people who are obese, over 800 million people who have diabetes. If the drug was made available to everybody across the world who needs to be on it, who would qualify for it, what would be the impact? We modeled it, and our answer is dramatic. If you're able to deliver the GLP to everybody across the world who needs it, that's about 27% of the world population at affordable cost, you would save about 30 million deaths in a 5-year period, and you would halve the prevalence of obesity worldwide. Okay, but the challenge here is twofold. Number one, you need to lower the cost and make it available to people that need it. And second, you need to make sure its use is going to be appropriate and consistent. The last thing you want is people trying it out and going off it. And the worst thing you want is people using it playfully for trying to lose weight before they go to the beaches or something like that. I think that's going to be the challenge here.
Mm-hmm.
Alka?
Yeah, I agree. These new drugs are revolutionary in how we should treat diabetes, as well as other conditions like heart disease and fatty liver. I think the jury is out on the long-term effects. And what I worry about is the long-term effects on muscle mass in South Asians. We have the lowest lean muscle mass of any population group. And when you lose weight on these drugs, you lose fat and muscle. About, they say 60% fat and 40% muscle in most recent studies. My worry is that when you come off of these drugs, and most people want to come off of these drugs, you regain the weight. It takes about 1 to 2 years to regain all the weight you may have lost. But when you regain weight, you regain mostly fat and not muscle. So you end up worsening the low muscle problem that you started with. So the jury is out in terms of long-term effects on muscle. And that is my one cautionary note about these drugs. I think they are otherwise immensely helpful and will be, game changers. And as we get newer agents, I'm hoping that the muscle effects will be attenuated. They'll be lower in those.
Did we lose Alka?
She's here.
Oh, no, she's here. We heard her.
Nalini,
Hello?
I think you're
Everybody's here.
I think you're
I think
frozen.
Nalini's connection is, she's in India right now. So I think.
Yeah, I think Nalini is off. So can I pick it up, Amita?
Yes, please, Emma. I can send you a few of the
there.
questions. Oh, there she is.
Okay. All right. Sorry.
Nalini, you back?
Amita, we're out of time. Can we take 10 more minutes?
Sure.
Yeah, sure. I mean, I sent you a few questions, Nalini, if you wanted to take a
Amita?
look at them. Yeah, can you hear me?
I think she's fading in and out.
Yeah.
Yeah.
Nalini, you can take a few more of the questions that I sent you. Maybe
Yes.
another 5
Okay,
to
all
7.
right.
Yeah.
So we've covered so many points. We really didn't cover AI, and I do believe AI is very correct for lifestyle change advice. So I would have liked to have covered that. But some of the questions here are really great, especially there's one on fasting. What is the effect of fasting on diabetes? And then can it actually be reversed? Can diabetes be reversed? I think these are very important points. So whoever wants to answer it, maybe Alka?
Yes. Yes. So there have been really good studies that show that people with new diagnosis of diabetes can reverse diabetes by usually weight loss. Weight loss is the one thing that has been shown to be most effective in getting out of the diabetes range for your fasting glucose and into the pre-diabetes or normal range. So I do think we can, but it has to be very intentional. And again, has to be a lifestyle change that you can use for the entire life. What was the first part of that question?
Fasting, the effect of fasting.
Fasting.
Yeah, intermittent fasting and other, 16-8, et cetera. They've all been looked at in good, well-done studies. And I think of them as another type of diet. It's another type of restrictive diet. So, you can choose if you want to cut down on calories that you eat and what types of calories you eat by reducing carbohydrates, reducing fat, reducing protein, or reducing the number of minutes or hours that you eat. So it's another way of reducing calorie intake. I don't think there's anything magical about these diets in terms of metabolic resolution. It's all about the number of calories you're getting in.
Right. So Venkat, more interest in the link between diabetes and Alzheimer's or other complications. Can you talk about that? Not necessarily your research, but what is the link?
Again, the literature suggests that people with diabetes are at higher risk of cognitive decline and also potentially dementia. But what is not clear is whether is it the diabetes itself, is it some shared mechanisms, or is it because of, does glucose control, or is it the vasculature that is affected? And then there's also been studies testing anti-diabetic therapies and their effect on dementia. I mean, some things like GLP-1 have been shown to reduce certain types of dementia, risk of dementia, etc. But this field, again, we don't know enough. I mean, because there are different types of diabetes, different types of dementia. So what we know is there is a link. The larger theory is diseases like diabetes and hypertension may accelerate dementia. But what type of dementia? And those are the kind of questions. Generally, people would say currently, to prevent dementia or cognitive decline, there are 13 or 14 things that you can do. Among them is controlling your diabetes or preventing it, controlling your blood pressure, better diet, better physical activity, better sleep. Those are the kind of, so there's a commonality between the risk factors for all these conditions. So that's another thing. We need to start looking at these conditions as they're related, whether it's diabetes, dementia, cardiovascular disease, kidney disease. They share a number of risk factors, and I think managing them simultaneously. We should take diabetes out of specialty and send them to primary care like Alka manages.
Yeah. Ravi, do you want to comment on that as well?
Sure. So, I mean, Venkat actually alluded to it in a perfect manner, in the sense that if you look at diabetes, like I mentioned in response to your first question on why do we get heart disease and diabetes, one of the aspects I mentioned was the flow to the heart is diminished or it's not normal in the diabetic people. same thing happens. So if the flow to the brain is affected, which is in fact being affected in diabetes, you are going to get a vascular deficit in the brain, and therefore that can lead to dementia per se. So from that point of view, that's well established in large preclinical studies and some of the earlier clinical studies as well. So that's definitely a contributing factor. Vascular deficit is a major contributing factor to dementia that you see in diabetes.
Okay. So there's a question on clinical studies, if there are any clinical studies on alternative therapies like herbal supplements and Ayurveda for diabetes care. And does anyone want to comment on that?
I don't know that literature.
There's many small trials that have been done in India, looking at jackfruit, looking at Karela, looking at other herbal compounds in Ayurveda. They suffer from having very small numbers of people, those studies, and aren't long-term. So there may be some, short-term benefits of some of these Ayurvedic and other types of foods, but we don't have great long-term studies.
Okay. All right. I'm going to have to, bring this to an end, but I wanted to say, I wanted to come to one point. All of you have given us lots of food for thought. Diabetes is very complicated, especially in South Asians, and there's a lot more we have to understand. But hey, by and large, you eat right and you exercise, you get good sleep, you avoid stress, and you go for a walk, and chances are very high that you'll manage your life well. May be difficult to reverse it, but it's there is genuinely a role for improved diet. I learned a lot from this, but I wanted to say, Venkat, of all the things I've read in the Lancet, I was most proud to see your name as the single author for that Copenhagen Declaration. And it's really a matter of pride for us as a community that you're, the undisputed single person that the whole community has rallied around. So I want to just end this thing very quickly. For 30 seconds, if you can tell us what, led to that Copenhagen Declaration and what are the implications for governments?
Yeah, and this was the declaration was a project, a one-year project sponsored by the Novo Nordisk Foundation, which is the world's largest philanthropy. So it was motivated by several factors. Number one, the fact that diabetes is a huge global disease. And secondly, the recognition that there are different subtypes of diabetes, heterogeneity and different types of diabetes. Like we said, in certain populations, there's more of insulin deficient type of diabetes. So there's a lot of variation across the world. And thirdly, the rapid development of molecular technologies, wearable technologies, and of artificial intelligence. So taking all that into account, what are the opportunities to better understand the disease and to better research into it? How do we change this research gap between where the burden is? Because unfortunately, the burden of diabetes is in low and middle income country populations, but we continue studying it in high income populations. I think there is a disconnect there. So we wanted to change that. And so I think that was the motivation behind the Copenhagen Declaration. And the other important thing to remember before we close is, we may not be doing a great job, but in the last 20 years, the mortality rates and complication rates for people with diabetes in high income countries, starting initially in the United States from a lot of the work that is done by CDC, NIH, ADA, etc., we see a decline. So people with diabetes in the US are now living longer, and their complication rates are on average lower. But in low and middle income countries such as India, China, across the world, the complication rates and mortality rates are increasing. So this was a very important point of our Copenhagen Declaration, that it's time to replicate the successes that we have achieved in reducing complication and mortality in people with diabetes in high-income countries by applying simple methods like task sharing, like the use of mobile technology, like the use of simple things like making essential medications affordable. So that was the whole idea. So our hypothesis is, if you did that in 10 years, like they achieved in HIV and AIDS, there's no reason why people with diabetes in low and middle income countries cannot have lower complication rates, lower mortality rates, and better quality of life. That was the whole idea behind the Copenhagen Declaration. And that was a collection of 50 odd experts from across the world, half from low and middle income countries and half from high income countries.
Thank you. Thank you very, very much. So I'm going to end this right now. Thank you, Indiaspora, for giving us this opportunity. There's just one take-home lesson for all of us. We have to, as a people, as a community, as patients, as pre-diabetics, bring that blood sugar down, because blood sugar for long periods of time leads to lots of complications, as we have seen today. So thank you all very, very much, Indiaspora, especially for the opportunity to talk about diabetes. Thank you.
Thank you, everyone.
Thank you.
Thank you to our panelists. Thank you, Dr. Murthy. As you all know, this is part of our ongoing health series at Indiaspora. So please tune in to learn about more health challenges that affect our community. We're all going to go and work out a little bit, build some strength, contribute to research in any way that we can. And on a last note, the importance of community in wellness was highlighted today. And I think that's something that we all want to take home with us. So thank you, everyone, for this wonderful support that you've shown us. Good night.
Thank you.
Thank you.